Okay, class, today we're going to talk about how do we draw special segments on a graph. And by special segments, I'm talking about altitudes, medians, perpendicular bisectors. The first one we're going to do is a median. And if you remember correctly, a median is a line segment that goes from the vertex of one part of the triangle to the midpoint on the opposite side. So the first thing that we need to do is we need to find the midpoint. And then once we find the midpoint, we can connect a line from the midpoint straight up to the opposite vertex. So the first thing we need to do is remember our midpoint formula. And we're going to start and we're going to find the midpoint of AC. And if you remember correctly, all we're doing is we're taking the average of our x coordinates and the average of our y coordinates. So if I take 4 and I take 8 and I do 4 plus 8 is 12, and then 12 divided by 2 is 6. So the average of 4 and 8 is 6. So I know I'm going to be somewhere on x equals 6. And then I'm going to take the average of my y coordinates. So 8 plus negative 2 is 6, and 6 divided by 2 is 3. So the midpoint of AC is going to be at the point 6, 3. So I go 1, 2, 3, 4, 5, 6, up 1, 2, 3. There's my midpoint, and if you look, it looks like it's right in the middle of A and C. And now we're going to connect a line from the midpoint to the opposite vertex. So I just go straight here from the midpoint to the opposite vertex, and now I have a median. So now let's do the same thing with AB. Let's find the midpoint of AB. So I'm going to take 4 plus negative 4 is 0, and 0 divided by 2 is still 0. Then we do the same thing with my y coordinate. Negative 2 plus 8 is 6, and 6 divided by 2 gives me 3. So my second midpoint is at 0, 1, 2, 3. And again, it looks like it's in the middle. And so once again, I'm just going to connect that midpoint to the opposite vertex. Okay. And lastly, we need to find the midpoint of BC. So again, I'm going to take my x coordinates. So negative 4 plus 8 is positive 4, and positive 4 divided by 2 is 2. And then I take negative 2 plus negative 2, and negative 2 plus negative 2 is negative 4. Negative 4 divided by 2 is still negative 2. So if I have the same two numbers, the average is going to be negative 2. So here is my point at 2, negative 2. Oops. There's my point. And so now once again we are going to connect that midpoint all the way up to the opposite vertex. And again, here are my coordinates, 0, 3, and 2, negative 2. So here we have three medians. And quick review question, where all the medians intersect, what do we call that? We just found a centroid. All right? So that is how we find the location of a centroid on a triangle. We have to find the three medians, and then where they intersect is our centroid. So it looks like it's somewhere between 3 and maybe about 1.5 is where our centroid is. So now we're going to do the same thing, except we're going to draw an altitude. Okay? And to draw an altitude, we need to first find the perpendicular slope, because remember, an altitude forms a 90-degree angle, which means that line has to be perpendicular. Well, in order to find the perpendicular slope, we have to first find the initial slope of our lines AB, AC, and BC. And once we find the perpendicular slope, we're going to start from the opposite vertex and construct a line using that slope. Now, I know that sounds complicated, but it's a lot easier than it sounds. The first thing we need to do is we need to find the slope of AC. So to find the slope of AC, we do rise over run. So I go down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then I go over 1, 2, 3, 4. So down 10 over 4 means my slope is going to be negative 10 over 4, which reduces to negative 5 over 2. But now I want to find the perpendicular slope of that. So to find the perpendicular slope, we're going to flip it and change the sign. So instead of it being negative 5 over 2, it's going to be 2 over 5. Okay, and like I said, we're going to start from the opposite vertex and use this perpendicular slope. So if I am at, if my line is AC, I'm going to start at B, okay, and I'm going to go up 2 over 5. 1, 2, 3, 4, 5. So now all I have to do is just connect a line from B all the way through that point. Now we have our altitude. It forms that 90-degree angle. Now we're going to do the same thing, but we're going to do it with AB. So I start at B, I go up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and I go over 1, 2, 3, 4, 5, 6, 7, 8. So I went up 10 over 8, so my slope is 10 divided by 8, which reduces to 5 over 4. And then to get the perpendicular slope, we're going to take that number and do the opposite reciprocal, which gives me negative 4/5. So now what I'm going to do is I'm going to start at C, and this is going to be a little different because I'm going backwards. So if my slope is negative 4/5, I'm going to go 1, 2, 3, 4, 5, up 1, 2, 3, 4. So if you think about it, if I start at this point, I went down 4 over 5. And now that I have this line for these 2 points, I can draw my altitude. And one more time, we're going to find the slope of BC. And if we look, the slope of BC is a perfectly flat line. So that means the slope has to be 0. And the perpendicular slope of 0 is undefined, which means it's going to be vertical. So we really don't even have to count. I just know I'm going to make a line, sorry about that, straight down from my vertex. And there we have our 3 altitudes. Now they're not perfect, but you notice that there should be an intersection somewhere in there, and that's how we find the orthocenter. Remember, the orthocenter goes with my 3 altitudes. So somewhere in there is a point, somewhere in there is a point that we call our orthocenter. So right there, that little red point is what we would call our orthocenter. Okay? Now we're going to do the same thing, except we want a perpendicular bisector. Now, perpendicular bisector means it's got to make a 90-degree angle, and it's got to go to the midpoint of the opposite side. So it's kind of the combination of the 2 things we just did. We need to first find the perpendicular slope, and we're going to start from the midpoint this time. Well, we already have done that when we did median. We found the midpoint. And when we did altitude, we found the perpendicular slope. So if you remember, our midpoints were here. And here. And here, of course, are those midpoints that we found earlier. Okay. And then we also had those perpendicular slopes that we found with the altitude. If the slope of AC was negative 5 over 2, then the perpendicular slope was going to be 2/5. And if the slope of AB was 5/4, then the perpendicular slope was going to be negative 4/5. And since the slope of BC was 0, then the perpendicular slope was going to be undefined. It was going to be a vertical line. Okay, so now that we found our midpoints and we found our perpendicular slopes, we can create our perpendicular bisector. And so what I'm going to do is I'm going to start at the midpoint and use my perpendicular slope to construct this line. So if my midpoint of AC is 6'3", and my perpendicular slope of AC is 2/5, I'm going to come start at my midpoint, and this one I do have to go backwards. But since the slope is up 2 over 5, I can also go back 5 and down 2. Now that I have those 2 points, all I have to do is connect them, and we have our perpendicular bisector. And if you remember, a perpendicular bisector doesn't necessarily have to go to the vertex. And now we're going to do the same thing. If the midpoint of AB is 0,3 and the perpendicular slope of AB is negative 4/5, I'm going to take my point, I'm going to start at the midpoint, and I go down 1, 2, 3, 4, and over 1, 2, 3, 4, 5. So now I have that, and I can connect them. And lastly, the midpoint of BC is 2, -2, and the slope is, the perpendicular slope is undefined, so it's going to be a vertical line. So I really don't have to do any counting. I just start at the midpoint and I go straight up. And if you notice, all three meet at a common point. They all intersect, and so we call that the end center. So right here, where all three perpendicular bisectors intersect, is called the end center. So this last point, again, is the end center.